Okay, so just imagine that so let's say mother has two children, okay, and you know mother's utility is just a function of the sum of the utilities of the two children. Okay, it's kind of makes sense, right? I mean, mother really cares about the children, you know, and she loves her children, and her utility is the sum of the utility of her children. Okay, so you know I'll present a problem, and then you know you can just try and solve it. Okay, so just think of it in this way: children wants their mother's time. Okay, and then of course the more mother will the time the mother will spend with child one, you know, the higher the satisfaction level child one gets, the more time the mother spent with child two, the higher the satisfaction level that child two gets, you know, and mother only cares about children's satisfaction. Okay, so you know that's the kind of thing that we keep in mind, and I'll just set up a model, and then I'll come back to the story and I'll just tell you exactly what is going on. Okay, is this fine? Okay, so suppose u1, so this is let's say the child one utility. Okay, child one's utility as a function of you know the time that the mother spent on this child. Okay, so let's say t1. Okay, so u1 t1 is let's say you know so again I'm just giving some function, please don't take it, okay, this is just a model. Okay, so it's totally you know I mean obviously depends on the person. Okay, so please you know so let's say you know it is some concave function, and u2 t2 is okay, so utility of the mother is t1 t2 is a function of, in fact not t1 t2, but let's say u1 u2. Okay, and of course that is given by this, so which is let's say u1 plus u2. Is this fine? Okay, so though you know I think this is also not necessarily the case. Mother don't really care about the sum. I mean, I'm not saying all mothers, but let's say mother might care about you know I mean both should get equal satisfaction level, something like that. In that case it could be like min of u1 u2 or something like that. I mean I'm just telling you, I mean you can just tell so many stories with function. That is what I'm saying, you know, it's just amazing. Okay, so let's say this is the function for the time being. Okay, of course we can always, we are not saying this is necessarily the case. The point here the point that I'm making here is this: mother cares about you know the happiness of their children. Okay, children obviously values the time of their mother. Okay, they look for it. Okay, they look for their attention of the mother. Okay, and you know it is eventually up to the mother how much time she is going to allocate to their whatever you know whatever needs. Okay, so obviously mother also has other work, she also do a lot of household work, a lot of other things, you know, her own professional work, you know, a lot of things that she actually do all the time. Okay, so what we are going to do is we'll fix some capital T time, which is a constraint that she cannot spend more than this. You know, of course she would have loved to because her utility is increasing, but there's a constraint. She only has this much time that she can spend. So how will she allocate, you know, assuming that she knows the children very well? So let's solve this problem. So mother wants to maximize her own utility, which is the sum of the utility of the children. Okay, so maximize t1 with respect to t1 and t2, 2 root t1 plus t2. Okay, fine, because that's the sum of the utilities. Okay, subject to the constraint that of course you know there's a limited time that the mother has, T1 plus T2. We can solve it for all T basically. Is this fine? Okay, and of course T1 is non-negative, T2 is non-negative. Is this clear? Is the problem clear? We just thought of a story and we just modeled it as a math problem and we can solve it. Okay, fine. So why don't you solve it? Of course, the solution, is, I mean, there's no name to it. You can give one name, whatever you want to call it. Okay, so here, of course, the solution will depend on capital T. So whatever the solution is, that will depend on capital T. Like remember, demand function was a function of prices and income. Hixon demand was a function of prices and the target level satisfaction. Here, the time allocation of mother to her children is a function of the total time that she has. Okay, the constraint, which is capital T. So you can call this model "Mothers Are Amazing." Okay. Yes. So yes. Just a minute. 1 upon. Is it 1/4? No, I think it should be. So I think it should be like this. Okay. So T1 is min of 1, comma capital D. Okay, and T2 is max of 0, comma T minus 1. Is that okay? Are you all getting this? You can plot the constraint and then you do the usual thing. Okay, just plot the constraint. The constraint set will be like this. Okay, and then plot the level curve. Okay. T1, T2 space, plot the level curves. Okay, and yeah, so basically, what you want to get is this, the solution will depend on T. Okay, the reason is because let's just let's figure out the slope of the indifference curve of the mother. Okay, so what is the derivative? So what is the satisfaction level utility? What is the derivative of the utility with respect to T1? One upon root T1, right? Divided by the derivative of this, which is 1. Okay, what is the slope of this? 1. Okay, now the thing is that if you just look at the slope of the indifference curve, okay, 1 upon root T1, it's a quasi-linear function. Okay, because it's linear in this and non-linear in this. It's a quasi-linear function. Okay, so if you see, if you equate this to 1, what are you going to get? What you're going to get is 1, right? T1 equal to 1. Okay, but that is only possible if capital T is greater than 1. Because if capital T is not greater than 1, you cannot get 1, right? Because if the total amount of time that the mother has is, let's say, 0.8, how can she allot 1? Okay, so basically, what will happen in that case is, so if this term is greater than 1, so let's say 1 is here, okay, then the solution to this problem is like this. That's the solution. Okay, because then T1 will be 1 and T2 will be whatever is the remaining time, T minus 1. Is this clear? Okay. If, however, 1
Yes,
is
sir.
here. Sorry?
Sir, could you please repeat this one?
Yeah, so if T is greater than 1, then this is the optimal choice, right? I mean, because it's feasible, right? So, you know, the IC, the slope of the IC will be equal to the slope of this line. Okay, so yeah, I mean, if obviously if 1 is possible for the mother, then in that case, you know, this is how the situation will look like. If, of course, you know, 1 is not possible, then this is how the situation will look like. You know, in that case, you know, if we compute at this point the slope of the indifference curve, so the slope of the indifference curve of the mother will be will be 1 upon root capital T. Okay, and 1 upon root capital T is what? Is greater than 1, right? Because T is less than 1. Since T is less than 1, so root T is also less than 1, and therefore 1 upon root T is greater than 1. So that means at this point the IC will look like this, not like this, but it's still downward sloping, but okay, but you know, it will be like this, because you know this slope is 1 in absolute terms, and the mother's IC is steeper. Okay, so this is how it's going to look. Is this fine? And in that case, the solution will be T. Is this fine? Okay, so that is why I said that it is minimum of 1 comma T. So if T is less than 1, then the solution is T. If T is greater than 1, then the solution is 1.